Okay, so today I'm going to be going over how to do question 4 from contest 1 called Journey to the Moon. So I'm going to assume that most of you have read the question already from the contest, but for those of you who haven't, I've put together a short summary. So there are n astronauts numbered from 0 through n minus 1, and we're given p pairs of integers a comma b such that astronauts A and B come from the same country. And you're asked to count the number of ways to send 2 astronauts from 2 different countries to the moon. So in this example, n equals 6 and p equals 3, meaning that the astronauts are numbered as 0, 1, 2, 3, 4, and 5. And these 3 pairs of integers tell you that astronauts 0 and 3 come from the same country, astronauts 3 and 2 come from the same country, and astronauts 1 and 4 come from the same country. So I've made an illustration here where I connect 2 astronauts with an edge if they're from the same country. So 0 and 3 and 2 are all connected, 1 and 4 are connected, and 5 is just by itself because it has no connections. So what you can kind of tell from this illustration is that you can send any pair of astronauts that have different colors, because within one color, all the astronauts are from the same country. Right? 0 and 2 are connected, or they're not directly connected, but through some series of edges they're connected. So basically, all we need to do is find all the connected components of astronauts, and then for each connected component, you can multiply the size of that connected component, meaning the number of astronauts in that group, by the number of astronauts not in that group. So that'll basically count taking an astronaut of this color and then an astronaut not of that color. So that's the number of possibilities, and then you can do that over all connected components. And then the sum of all of that will be the answer times 2, because every pair will be counted 2 times. Okay. So now I'm going to actually code a solution to this problem, so you can actually see the code. So in this problem, n and p are the first 2 things in input. And then the way we're going to represent these p edges is through an adjacency list. So how an adjacency list will work is like, we want EDJ list of I to be an array list storing the nodes that are adjacent to node I. Okay, so it's gonna work like an array of array lists. Okay, and then in the beginning they're all default at null, so we're gonna have to initialize all of them to just an empty array list. Okay, then we need to read in that the p pairs. So we want to add v to EDJ list of u, meaning that v is adjacent to u, and then also the other way around, because they're both like it's a bidirectional edge. Okay, so now we have to actually find all the groups, or in this illustration, all the colors. So we're gonna store in array list where we'll add the sizes of the groups. So like, for example, in this example, we would want groups to contain eventually like 3, 2, 1. The sizes of the groups. This is 3, this is 2, this is 1. Okay. And then in order to do a flood fill, we're going to also need a Boolean array that marks whether or not we've already processed a certain node or not. Okay. And then we're going to actually go through all the nodes. And then if we haven't processed the current node, then we have to process it and then mark it as processed. So as visited. Okay, so when we process a node, we have to go outward and mark all of the nodes that are in the same connected component as this one, as visited, and then add that to the current group, right? So if you start at 0, you need to propagate outwards to 3 and then to 2, and then at that point your group size will be 3, at which point you will add 3 to groups. Okay, so this part of the code, I'm going to code BFS, which I assume many of you know already, but the way I code BFS may differ from the way you are used to, but I think if you know the algorithm, this part of the code should be pretty self-explanatory to you. So I'm just going to code BFS for now. So current group is going to be the size of the current group. So it starts at 1 because it's just node I itself. Okay, but then we have to propagate outwards to I as the neighbors, and then increment current group. So we're gonna keep propagating outwards as long as BFS is not empty, and then temp is gonna serve as like the next layer of propagation in the BFS, and then like we're just gonna keep going outwards, and then at the end of this we set BFS to temp to kind of move on to the next layer, and then we go through all the nodes in BFS, and for every node in BFS we want to go through all of its neighbors. So all of its neighbors are an ADJ list of U. Okay. So to process all of these, we want to check if they first have not been processed yet, and then process them and mark them as processed. So viz of v equals true, and then you also want to add it to the next layer in the BFS. So add v to temp, and then we also need to increment the size of our group. Okay, so at the end of this, current group will represent how many nodes are in the group. So we can add that to groups. Okay, so at this point we're almost done. We just need to actually compute the answer by summing up all those products. So if you notice in this problem, n is actually quite big, and the number of pairs could be on the order of n squared. So that would be n to the 10th, which can actually exceed the int capacity. So we need to use a long for our nth variable. And then we're just going to go through all the groups. And then for each size, we're going to increment n's by the size times n minus the size. Because the size represents how many astronauts are in this group, and the n minus size are how many are not in the group. So that ensures that you only count pairs that have different colors or come from different countries. One small problem with this is that this is int times int, which will probably overflow when the numbers become too big, so we have to do 1L times size, so that this will become a long, and then this will become a long. So when you add a long to a long, that's fine, because when you do long times int, it becomes a long. So at this point, well, we have the answer times 2 because we overcounted every pair by 1, so we have to print ans over 2. And this should be a complete solution. So I already have the sample case in test.in over here, so I'm going to run it to see if it works. Okay, and 6 is the correct answer, so I'm going to change the system that in and then submit it. Alright.